Welcome to another live session. Really excited for this week's live session to bring on Puppygraph, which is a partner that we've been working with. And so I wanted to quickly introduce myself really quick. I'm Tony. I am the technical content and partnership strategist here at DevRel. So work closely with a lot of the external partnerships, including Puppygraph, and really excited to bring on one of the co-founders of the company. And so I'm going to introduce Waymo. And Waymo, there we go. Hello. Hey, Waymo.
Hello,
How's it
Tony.
going? Just wanted to quickly introduce Waymo here. So Waymo is one of the co-founders of Puppygraph, based out of the Bay Area, San Francisco. So really excited to have you here. So what we're going to be discussing today is really kind of a backstory of, like introducing what Puppygraph does and uncovering what Puppygraph can do in terms of visualizing the relationships with MongoDB collections using some of the graphing modeling techniques. And so we're going to uncover how we can transform MongoDB documents into graph structures without having to use like an ETL pipeline, and how users can really intuitively essentially query and explore a lot of different complex connections and see what we can do with Puppygraph. So Waymo, do you want to do a quick introduction of yourself, of like your history, and also kind of like how you founded Puppygraph? And yeah, let's start with that.
Hi, everyone. Thank you, Tony, for the opportunity. I'm CEO and the co-founder of Puppygraph. Before that, I worked at TigerGraph and also Google F1 team. TigerGraph is a graph database startup, and Google F1 is a unified SQL query engine inside Google. It can query all the data format and the data source, like JSON file, proto, logs, and also spanner, and all the others can be queried as with a SQL statement. And then what I'm thinking is that maybe we can merge this technology together, since when I was at TigerGraph, engaged with a lot of customers who want to try graph database, but it's very hard to be in production. There are a lot of investment before they see the value. So I think, if we can just query the existing data as a graph, I think the barrier will be much lower, and this is how we come up with Puppygraph.
Awesome. And I believe you have another co-founder with you that helps work with this. But yeah, we'd love to know now, kind of just do like a kind of storytelling of like, knowing that we've had a couple publications already with Puppygraph integration with MongoDB. Could you tell us kind of like how that all kind of unfolds and like how does that work?
Yeah, to support MongoDB as a data source is a request from one of the largest cybersecurity company, and they already have some data in data lake, and also they have a lot of important data in MongoDB, since they have different configuration of different machines, and I think the raw data may be Parquet file, maybe maybe YAML file, maybe JSON file. And then because they want a very flexible storage, so they choose MongoDB to store the configuration. But when they want to have some dashboard, like most cybersecurity company do, and they want to show how many vulnerability is related to this device, and there are different other kind of information. And at the beginning, they load all the data from MongoDB to Redshift, and then write very complex SQL to do that. But then they realize, maybe they can use a graph database, but it's very hard, since they need to duplicate the data, and also because MongoDB scalability is pretty good, and while most of the graph database scalability is not as good as MongoDB, so the data loading will be a big trouble. And then they reach out to us and also ask us whether we can directly support MongoDB. And then we think, this is what we didn't think about it before. We just at the beginning we just support the data lake, but in theory there is no difference, right? So then we work with them together to and to working on some real use case. And we feel, oh, this is pretty cool about MongoDB. And also we talk with some our friends from Neo4j. They said that some of their users just loading data from MongoDB to Neo4j just for graph visualization. I think, oh, this in this case, maybe we can make both graph user and the MongoDB user life easier.
Gotcha. So it essentially with Puppy Graph, you're it sounds like it reduces a lot of the a lot of the weight that we had before with like the ETL pipelines. Do you know any other certain common challenges that you've seen people prior to using something like your product? What are some of the other challenges that you've seen without having any kind of the graph implementations?
Yeah, one is that how to build the graph schema and mapping to data source. And usually, if they have some experience, it's not a hard problem. But since honestly, graph technology is not well adopted in the last decades, so sometimes it's totally new to the graph. And in this case, we help them to have them auto tool, but we cannot guarantee the graph schema and the mapping is correct 100%. So we can just give a suggestion of the initial graph design, and then people can, based on their requirement, people can do the improvement on the graph schema. This is one of the bottleneck. Another is that sometimes graph analytic is a very heavy workload. Like they run graph algorithm like weak connected components or PageRank. In this case, they need to run the access all the data of MongoDB. Then we cannot do lazy fetch as much as possible. So we need to cache the data, especially when they run different algorithm or repeatedly run algorithm. In this case, we want to avoid the heavy workload for MongoDB because there are high QPS updates already there, and we don't want to lock the data. So in this case, we just have some CDC strategy and caching the data into Puppy Graph cluster to make the workload for MongoDB lighter. Yeah.
Gotcha. That's interesting. Talking more about the scalability part, when it comes to like some of the technical implementations, I definitely want to talk more about that. So like when it comes to, you mentioned that Puppy Graph, you can you work with sharded clusters in MongoDB, and how does it work well with like the distributed shards? It sounds like it does, right?
Yes. Since we are pretty good at to scale to more and more machines. So most of graph database, because they want to handle the data set in one single machine or even one single thread. In this case, it's hard to can only scale up, but it's hard to scale out. And even the storage is sharded, but the engine itself is a single machine or a single thread. So this is I think the biggest differentiator of Puppy Graph than most graph database. Since first we depend on other storage like MongoDB, because MongoDB itself is scalable and distributed. So the storage layer is scalable. At the same time, our engine is distributed as well. The workload will be sharded. Since when we a graph query or graph algorithm coming in, we will generate a query plan, and then based on the storage, we will generate the physical query plan, and then for each machine, each compute node, what we can do is that each compute node have a part of the logical plan and all the physical plan, and then we can fetch the data from the different shard of the storage layer, like MongoDB shard 1, MongoDB shard 2. And after that, because the graph computation is highly connected, and then the data will shuffle between the machines. Since at the beginning we know that this is a little bit different than SQL. Since in SQL, if we already have, for example, 10 compute node, and each compute node will only handle certain partition of the data. But for graph, if you do the graph traverse, the first iteration may be every computer machine have a partition. But laterly, because data between partitions are highly connected, you never can predict what happen next. So the data need to shuffle between the cluster. So this is how we design to handle the distributed workload. And the lucky thing is that we try with a lot of customer have petabytes of data, and wow.
Gotcha. That's awesome. Does it also, so it sounds like it works well with like a distributed system, like horizontally. What about systems that are vertically scaled? Like, is that also accommodating as well? Or is that approach different?
It's almost similar, since only when we fetch the data, the difference is only when we fetch the data. Since if is the storage just scale up, and then we always need to fetch the data from the same node. This is the main difference. But after that, the computation on public graph is still sharded and in a distributed environment. And we can even support multiple data source. Like I think one of the common practice is that some data in Mongo, some data in data lake like Iceberg or Databricks. In this case, we can have one unified graph schema, and some nodes or edges are in Mongo, some of them are in data lake. But for user, they only need to issue the graph query to public graph cluster, and the public graph will handle this data need to fetch from Mongo, this data need to fetch from data lake.
Oh, gotcha. So it kind of helps unify everything into one.
Yeah.
Okay, gotcha. That's awesome. And I think we've already kind of covered this, but want to touch a little bit deeper into how does Puppet Graph handle like the performance of when you're querying like a very large collection, like in MongoDB?
Yeah. Since MongoDB is focusing is a database, so it's very good at LTP and ACID, high QPI, CRUD, this kind of stuff. And what we are doing is mainly about OLAP. So first, we don't have a feature to about ACID and the transactional features. So we sacrifice these features to make the analytical query performance better. And what we are doing is that we define the basic operator like node action and edge action. So the collection will be a collection of nodes or a collection of edges. And in this case, every graph query or graph algorithm can be a combination of node action or and edge action. And then we can do the cost-based optimization. And for a single operator, because the input is a collection of edge or nodes, so for single operator, we can do vectorized evaluation, and also we can do multi-thread computation. In this case, we can make it faster. Yeah.
Gotcha. Okay, awesome. Yeah, thank you for explaining that. Kind of talking more about the architectural side of things. Is Puppet Graph able to handle, like when it comes to like concurrent graph queries? How does it handle that? Like when it comes to concurrent graph queries against like maybe the same MongoDB cluster that we're dealing with?
Yeah, since the MongoDB is through output is very good, so actually we can just one design that we can just lazy fetch from MongoDB, like we fetch the data with filter, and only necessary data of a single graph query will be fetched from Mongo. And when there are a lot of query coming to Puppet Graph, and then we can try to fetch the necessary data to MongoDB But of course, we will cache the data to make the workload to read from MongoDB not as heavy as repeatedly fetch the same data. So it's in this case, because we are OLAP system, so usually the requirement for QPS is lower than MongoDB. So it won't be a problem for the concurrency. But at the same time, some of users propose that if we keep reading MongoDB with very high frequency, and especially the OLAP workload will retrieve more data than the normal workload of MongoDB. Since for the common use case of MongoDB, usually the query is simple and only a small amount of data will be retrieved, rather than a big portion, big part of the data will be read within a single query. But for OLAP query, sometimes it will be maybe 1/3 of the entire data set will be read. In this case, we will try to read the data from the cache of a PuppyGraph first, and only when there is a cache miss, or we need to do CTC, like sync the updates from MongoDB to the cache, and then we will read from MongoDB to save the cost of MongoDB itself.
Gotcha. Okay, awesome. Really interesting. Would love to know, digging deeper, you've PuppyGraph is integrated with a lot of other customers. What are some, what would you say, like real world use cases of like, let's just say with PuppyGraph and then with like MongoDB workloads that would really benefit from like the graph layer approach? And yeah, would love to see like some of the use cases for those.
Yeah, I think we have a lot of use case. Since first, we depend on what user as current storage. Since if user currently use MongoDB, but I think MongoDB covered almost all the use case, and since it's pretty flexible, and when the developer builds something from zero, if they choose MongoDB, usually they can deliver much more feature because it's flexible and very easy to do the development. And then laterly they will add the analytical workload, like they want to see the insights. And in the traditional way, they need to do some ETL pipeline to load to maybe Snowflake, and maybe only a small portion will load to Graph database. Since usually if they can use some other like Databricks or Snowflake, usually is their first priority. But only when several use cases they will load to Graph database, because duplicate data and also the cost is heavy. Since it's a load from one database to another database, it's not a common practice in the big data world. But some use case like anti-fraud, supply chain is a have to. But for us, we see some new use case like not only the anti-fraud and supply chain, but also some, for example, cybersecurity, observability, and usually because the cost is very high based on the data volume, they won't use Graph database. But now they won't intro more cost to their existing pipeline, because they just add an OLAP layer, Graph OLAP layer on their MongoDB setup. So the cost will be much lower. So they at the same time, the graph pattern mode query can save a lot of their development time. And so they are pretty happy with the use case. And we also see some social network and the gaming company. And it seems that because data is always connected, so after the cost of graph technology is much lower, I think the adoption will be better. Yeah.
Gotcha. And you mentioned you have a lot of use cases for like the fraud detection. Is that that's just because it's more fitting in that kind of category, or is that something that's just very well suited with like the graphing course in general? Like,
Oh, yes. Yes, I think two cases of graph technology adopted more. One is anti-fraud, another is cybersecurity. I think this is because there are attacker and the defender. So
mm,
time attacker trying to make their pattern more
mm,
complex, and the defender also need to improve their capability. So it's so they are, because they're trying to beat each other, so they need to make the query more and more complex. But for some other
gotcha.
industry, if there is no adversary and it's
Yeah.
maybe some simple query is good enough. They don't need to write super complex query and even no people can read it. But for several cases, when there are people trying to compete with each other, and in
Mm.
this case, usually the query will be more and more complex. Usually in this case, graph is more useful. Yeah.
Gotcha. Okay. Yeah. Thank you. Thank you for sharing that. And talking more about like kind of like the functionalities and features that Puppy Graph can do. I know you mentioned you have utilizing like Gremlin and like OpenCipher. Is there any other graph query languages or algorithms that Puppy Graph supports beyond that?
Yeah, I think Gremlin and Cypher are the two most popular query language, and there are also some like Sparkle. We partially support it, but basically still based on the translator from Sparkle to Cypher or Sparkle to Gremlin. So it's not the first layer support. Yeah, but for graph algorithm, we support most of the popular ones, and
Mm,
also because we can leverage engine, so the graph algorithm is pretty easy to implement it for us, and it's highly based on our customer request. We have a roadmap, but once some customer have a request, we will make adjust the priority and make it higher it's a kind of a priority queue. Yeah, so in this case, we can support it first. Usually, algorithm can be delivered within 1 or 2 weeks, and
gotcha.
also we're trying to compatible with the most popular graph database. So there is already an ecosystem and a lot of tools like algorithm support or like NVIDIA. They have some graph algorithm to run on GPU, and
Mm,
also there are some popular visualization tool. And because we are compatible with most current graph database, most of these tool can directly run on top of PuppyGraph. So we're trying to bridge the data source community and also the graph community. Like in our case, we're trying to bring the gap between MongoDB community and also the graph community. And all the tool of each side can be integrated each other by PuppyGraph.
gotcha. Okay, that's awesome. I would love to know from your side. It sounds like like uh, Puppygraph really adds this layer to a lot of the databases that like even for Postgres 2, you can support that as well. Do you see this trend going with utilizing more of the graph queries and like with data becoming more increasingly complex? Do you think Puppygraph like is trending towards that suiting essentially?
Yeah, we see some trends since people will reach out through our websites or Slack community, and I think usually the common journey of our customer is that some of them use Mongo or Postgres. Some of them use data lake like Iceberg or Databricks, and some of them is the current graph database user. And usually they will public graph won't be their first choice. It's are more like an add-on, and they usually already have some data infra or data pipeline. And for certain moment, like they already write 5 or 7 drawings, or if a graph database user, they have data is close to 1 terabyte or even more. And also they have more and more relations, and also they want to deliver more complex features. And then they will coming to us, and our solution won't affect their current architecture. So this is I think one of the reasons they choose public graph. So all the existing architecture can run as it is, but then they can bring more value and deliver more complex feature or solve some scalability issue.
Gotcha.
Yeah.
Awesome. Yeah. Thank you. In terms of specifically talking about like the integration again with like MongoDB, what are some of the visual capabilities that you can do in PuppyGraph in the platform? If you want to do like a quick walkthrough of that, if you want to screen share or just like kind of talk vocally as well. But what can we do to what are some visual capabilities that you can see? And like in terms of monitoring and troubleshooting like graph query performance, how do you do that in PuppyGraph?
Yeah, I think one of them is like what cloud. I think a popular use case is cloud security posture management. Like Wiz, since Wiz is a very hot company in recent years, and there are a lot of other company working on the similar use case. What they are doing is that they collect different configuration. Like since everybody have a lot of machine, a lot of device on cloud, and each machine's configuration is different. And I think no human being can remember all the things. And some of them will have some attack path. Like each machine, like they have a JSON file or some other config file, and then can put it into MongoDB. And then what they're trying to do is that answer some question like which machine is not protected by any security group, but exposed to public IP. And some of them is that they want to return all the virtual machine they can access by some user, and also this user have installed some software, have a certain vulnerability. And then this kind of stuff is very complex in relations, and usually visualization or graph pattern can be straightforwardly show what happened. And also the one of the largest cybersecurity company who proposed we need to support MongoDB, they have a security research team. What they are doing is that they actually store every configuration in MongoDB and all the behavior in S3. And what they are trying to do is that they want to find who is the attacker. Before that, they already have a rule-based engine, or they do some machine learning technology. But after they try PuppyGraph, they can first visualize all the data on the screen. And then, for example, they just visualize the last day data, and then they see some weird thing happen. Like the attacker is very easy to find in the visualization, since most people just talk with several machines. But the attacker is talking with a bunch of machines. You can see a very high density in the visualization, and then they can click on the nodes and see what he's doing. And then they can, this is a new pattern attacker is doing. And then they can put it into the rule-based engine. and then retrieve back to last month's data, last year data to find there are some existing attacker haven't been found before, but now they can get them out. Yeah.
That's awesome. Yeah. That's really interesting. It sounds like you have a lot of stories from like customers and like a lot of fitting use cases here. When you talk with these customers too, whether that's using MongoDB or another database product, what are some optimization tips that you give them that helps improve like the query performance? Is there like a one for all strategy, or is it, in terms of like query performance and optimizations, what are some things that you suggest when people are starting to utilize with PuppyGraph?
I think different use case is very different. So we have some customized common practice for each kind of use case, and since we trying to be the click house and the tree node for a graph. So some of them want a real-time dashboard, and before they reaching out to us, they use like a 5 or 6 hop drawings, but now they when they were trying to grow to 7 or 8 hops, they consider about graph. So they reach out to us. In this case, they want to have sub-second performance because it's a dashboard. They need to let the user interactive with the dashboard. So they just click and render the dashboard. And also we have some customer want to have some offline analytic. So they want to run some complex graph algorithm, or they have some even they implement their own algorithm by the graph query language. And they want to have some graph traverse algorithm, like stop at what kind of situation, and BFS at what kind of a situation, and also DFS at what kind of a situation. In this case, it's a more like an offline one, and they care more about the cost rather than the performance. We will have a different strategy. And one of the differences that happened in cache strategy, like we have different mode of cache, like no cache or adaptive cache, or we have some full cache strategy, and it's not. But for the full cache strategy, we do some improvement based on customer request. Like we only cache the last 7 days data. So when the query only access the last 7 days data, it will be sub-second. And when they can access the older data, like last year, it will be single-digit seconds. So it's a trade-off between the performance and the cost. And yeah, so it's highly depends on the requirement of our customer.
Gotcha. So is every customer that you work with, is that custom or kind of like manually built to suit their needs at the moment?
Yeah, currently what we are doing is that we provide the different options in our configuration, so they can choose. Oh, this option is 1, 2, 3. We provide like the cache. We have option 1, 2, 3, and also whether sync the data into disk, or we just scale out when there is scale out when there is needed, and it's just different options for the engine. But we're trying to, based on our experience, different industry, the requirements are pretty similar. Like, for us, same industry, the use case is very similar to each other. Like for the financial technology and the banks, usually the anti-fraud, it will be offline one and online one. And for cybersecurity, if they want to support dashboard, the requirement is also very similar to each other. So we want to give some summary for different industry, and then they can just follow the common practice rather than think about a new idea case by case.
Gotcha. Awesome. Yeah, thank you for sharing that. When it comes to like really, we've been talking a lot about just business use cases here. When it comes to one of the blogs that we kind of that your team wrote, which is on the integration of PuppyGraph with MongoDB. Does it work well with the support of the aggregation pipeline that we have at MongoDB? And could you explain a little bit more about how that would work?
Yes. Since the most simple way to connect to MongoDB is just the JDBC, and then we can already achieve most of the use case. But of course, when there are more heavy workload like the aggregation case, thanks to PyMongo Arrow, since MongoDB already supports the Apache Arrow to access their data, so it's more efficient for analytic workload. Since Apache Arrow is the columnar storage in memory, in this case, we can just fetch batch of data from MongoDB, so bypass the JDBC.
Gotcha. Awesome. Thank you. And so now, kind of talking about like kind of the impact here, I'd be interested to know from you, like, do you feel like with this adoption, do you feel like there's going to be more essentially, this is a transitional solution, or is this like more of a long-term architectural pattern? Like, is this going to be viewed as more of like a transitional solution to where this is the answer, or this is just an alternative to like another architectural pattern that companies are approaching?
Yeah, I think it's a permanent architecture. Since actually I learned it from Google. Since I
Okay.
work at the F1 team, we work with almost every team inside Google. Since F1 is a unified SQL query engine, and we see that at the beginning, I think F1 became the unified SQL query engine because it supports almost all the data source and data format. Like based on my experience, of course, there are a lot of workload is in big table or capacitor file like column-based storage. But I think most of one is the Proto or JSON. So it's pretty flexible, and when people write it, they don't need to think too much about it. They just and also the schema can be changed and flexible like Proto, because the design is always change and they need to add more field in the Proto file. And I think this is also the advantage of MongoDB, because when someone, for example, build an app or a website, at the beginning they don't know where the feature finally goes. They need to add more and more feature based on customer request, especially for the good engineer with AI. They can do the development very fast. So they need to change the schema a lot. In MongoDB, it's not a big problem since MongoDB itself is very flexible. But at the same time, when they do the analytic, they want to make the complexity into the later stage, not when they're writing the data. When they're reading the data, they want to have more tricks. So when in Google, we can just let the SQL F1 the SQL query engine know, oh, this JSON file have this JSON schema, so you can select like a.b.c and plus like x.y.z, and from this folder and this folder, all the JSON file follow the same pattern or follow the same JSON schema. In this case, it's a kind of define a table on any file format like a JSON file, Proto file, and then just run the SQL. And I think in this case, Puppy graph is follow the same philosophy, because it's impossible for us to convince people like, oh, you need to rewrite all the data like this, or you redesign your current data pipeline like this. I think this is the reason why graph technology is hard to be adopted, since usually at the beginning no one chooses graph because the complexity of the problem is increased during the development, not at the beginning. Is after maybe several years, oh, they trying to solve the complex problem. And at this time, when they trying to bring the graph technology, they need to redesign all the things. It's impossible. But if they can be a plug-in to bring the graph to your current architecture, it will be much easier. And we will handle the complexity like, how to convert this like a JSON file or Mongo collection and into a graph. In this case, I think if we handle it underlying for the users and it's a better design, since we don't need to change the existing things, since no one know what will happen after we rewrite some part of the existing system. People always want to make the running system keep as it is, and then bring feature by have some add-on. This is how we design it.
Gotcha. I would love to know, like, I know you mentioned that, like, adding the graph capability adds more complexity. When would you say is the right time, would you say, for, customer solutions to like integrate that? Like, would you say like anytime's great, or is there a time that transition point is the easiest, has the least amount of friction?
I think one of the signal is that with the current implementation, and most people cannot read what the query is talking about. In this case, I think is a good signal that we can bring more capability. Maybe not only graph, but other technology as well. Since we see some, this is one of the story like we see from Lacework. Since Lacework is doing the cloud security first, but they just write and they call their product a polygraph. So they know it's a graph, but they use a SQL to do the implementation. And then no one can read the SQL script anymore. Since the feature is more and more complicated. And also this is why I think since this is, I think, why NoSQL is important as well. Since I think 10 years ago is NoSQL is pretty popular, but after that, because for example, Snowflake, because the SQL can handle the scalability with a good performance as well. So sometimes there is a theory that everything can be SQL. But based on my opinion, it's definitely not. Since like MongoDB is NoSQL, and also inside Google, we see a lot of just proto file, and people write in proto file and JSON file. SQL is not good for a lot of use case, but maybe it's just because the ecosystem and people have to choose it. But like MongoDB, it still grows very well for most case, because when people build some zero, the flexibility and write everything simple is also very important. So I think it's highly dependent on the use case. And sometimes people use SQL as a workaround. In this case, I think we can consider about whether we can choose some other technology to make it simpler.
Awesome. Yeah, thank you for answering that. And I agree. There's like data is only getting more complex too. And really the next question I have really actually touches based on like where we're going in the future, which is all about AI. And so I know Puppy Graph, I would love to see like what you're excited about. So like, what role do you think Puppy Graph can play in terms of like, and also where as MongoDB is also heading towards the direction of like AI advancements, what do you think what role do you think like Puppy Graph can play in like the broader like AI ML pipeline, especially like for like the knowledge graphs and like maybe like the neural networks? Could you tell me a little bit more of that forecast?
Yeah, I think and at the beginning, we don't think we are an AI company, but then customer reaching out to us and build their AI pipeline. So I think then we feel, oh, maybe it's a good opportunity for us, and we build some features for AI as well. One typical use case is that since there is a popular concept called graph rag, so they're trying to
Yep.
answer a question based on knowledge graph. And what's interesting is that people already have a graph. Like if people have maybe collections or tables like customer, product, and also order history and click history. Physically, they may be a collection or tables, but logically, it's already a graph. Since click history is one type of edge between customer and the product, and order history is another type of edge between customer and the product. And then people can use AI to answer some data-oriented question easier, like who is Jackie Chan's son's girlfriend. So
Mhm.
it's first that you can have a semantic of an edge, like who is whose son, and
Mhm.
then you have another type of edge, like who is whose girlfriend or who is whose boyfriend. In this case, we can just traverse from Jackie Chan to his son and to his girlfriend. And
Gotcha.
yeah, and in this case, the underlying data maybe in different format, but we can have graph modeling about their data. So it's a logical layer on top of their existing data. So you can treat it your existing data as a knowledge graph rather than build very huge knowledge graph from zero. I think in this case, it can benefit a lot. And also, we see the AI generate some graph query more smoothly in the last year. And in this case, we can have a logical graph to query several data sources. And then the AI generate query and answer the question based on the result. Then you can have some data-oriented chatbot.
Awesome. Thank you. Yeah, that's really exciting to hear. And like some of the use cases, what you could use, Puppy Graph for. And so to really wrap things up, I know we're getting close to the time here. And so we'd love to know like what are some like exciting things that you're looking forward to with your company and like the state of the future to kind of wrap things up here.
Yeah, I think one of the interesting part is that in logical layer, we can like a logical graph, and the AI can talk with it. So this is solve some of the long-existing problem, like because if people already super familiar with SQL, they prefer to do everything in SQL. And in this case, sometimes even a better use case, but they are still for maybe for graph, maybe for other NoSQL, people still want to do it. But for AI, I think it's more equivalent for different API, like graph query language, SQL query language, Mongo query language, and also some other APIs. And in this case, it's more depends on the use case, and I think it will bring us a more possibility. And also that I think we're trying to bring the graph to the modern data stack. So I think the modern data stack is a popular concept several years ago, but then it became everybody claiming themselves a modern data stack. But I think only, but I think only some companies, some database, some data tool are the modern stack, and we're trying to integrate with all of this, and then the craft technology can smoothly running on top of the modern data stack, rather than very complex and expensive investment before people see any value.
Gotcha. Awesome. Yeah. This was fantastic, and learning more about how PuppyGraph, and also we talked about how that can really complement with MongoDB. If for all the folks that are wanting to learn more about PuppyGraph and giving that a shot, like we have the links in the descriptions on like the YouTube channel and on LinkedIn, so definitely check them out. And thank you so much, Waymo, for being on and kind of telling your story and kind of like what your company does. It's been fantastic to work with y'all, and so like really do appreciate your time. And yeah, I will close us off now, and I hope to see everyone again in the next live stream. So
yes,
thank you
so much, Tony.
Yeah, of course. All right, take care, guys. Thank you. All right, bye.